lab, and so that eventually, if it is useful, you can have access to it. I remind you that my previous sessions are on YouTube. I have shared the links both in the Google Classroom and on Slack. So again, if you want to come back and have a look at some of the discussions we had in the previous sessions, you can. Okay, so the idea of this part of the hands-on is not really to ask you produce something particular, but more to ask you work together with me so that I can show you a set of alternatives that are available today when you are dealing with computing exercises that require having different tools in order, in our case, to process data. As you have seen in the previous days, it is not always easy to install and prepare running environments and cope with different characteristics of the machine. You sometimes have a reduced amount of resources. So these kind of problems are tricky problems because they you spend a lot of time solving them, and you do not have time to focus on what you really want to focus, which is data, and analyze them and query them, etc. So this is the intention of this hands-on, and I will use something that has been discussed particularly with Christophe, which has been data fragmentation in general. As you have understood, when volume starts growing, it is not possible to have the data in one single disk or persistent support, and also when your queries start getting a little bit complex, it is interesting to distribute the data and distribute parts of the process that you will use in order to solve the queries, so that you can exploit computing resources of cluster-like architectures. So first thing that we are going to do, as I said, is we are going to use the current knowledge that we have around the data fragmentation, and particularly sharding. And then I will show you how to use these kind of tools that let you get rid of the problems and limitations of your machine, and then try to externalize the processing of the queries and of the data. Okay, this is the intention of these hands-on. I suppose that being industrial engineers, that you will never really have to design a cluster or design such a solution, but it is important that you know also, because you are going to interact anyway with computer scientists, computing engineers that will have to solve these problems to you. So in order to ask and to give requirements, it is good that we have a little bit of background of what we are asking for. So first of all, I'm going to introduce some technical points of what we're going to use, so that you can be aware of all the manipulations that we will be doing later on. For those that didn't read or didn't follow the Slack channel, some days ago, I think that two days ago, I sent a set of instructions in order to prepare some of the tools that we are going to use, particularly creating accounts. If you didn't do it, don't worry, we will have time, you will have time to get on the same page and do these tasks that were supposed to be previously done. Okay, so if I can move my screen, what we are going to use is a very common technique today, which is virtualization. Um, when we are programming and developing applications, and when we are accessing, for example, cluster-like machines or cloud architectures, in order to get access to all these resources, normally a very useful solution is that you create a virtual space where you have a machine with all its elements installed in your machine that lives her life in an manner. And so you install this, you have the tools you require, you have even the data you require, and so you have this little kind of package, including an operating system, and then you install it in your machine, and when you do not use it any longer, you can disinstall completely, and this is transparent to your machine, okay? So virtualization has been around for many, many years, but today there are solutions that have evolved in order to make it very, very easy to use. So when you talk about machine virtualization, you can have two ways of doing it. You assume that you have an infrastructure, for example, a cluster, for example, the cloud, or for example, a machine. And on top of it, you are going to have a module that is called the hypervisor, which is a tool that will have the vision of all the resources possible, accessible in the underlying infrastructure. Remember that normally when we talk about resources in computer science, we are talking about storage, about CPU, and about main memory, essentially, okay? So these resources are there in different machines or in one machine, and so you have this hypervisor that gives a transparency layer where you can have a look at all these resources. And then on top of it, you can have different operating systems, and they are called guest operating systems. So you can have Windows, and then Linux, and so on and so forth. And up there, you have your libraries and then your applications. So in one environment, you will have different guest operating systems, as if you had different machines with their associated libraries and then applications, okay? This is kind of gives a little bit of burden, okay? So things have evolved lately, and today we have solutions, lightweight solutions, that give more transparency, particularly to let you manage your virtualization in an easier manner. So the idea here is that you will have always the infrastructure, and then on top of the infrastructure, you will have an operating system. And then on top of the operating system, you are going to reason in terms of containers. So a container will be a self-contained set of applications and data, and eventually that will use the underlying resources, okay? And on top of this is like as if you had your different little machines there, and then you have, again, your libraries and your applications, okay? So things have evolved there, and today we're going to use this kind of infrastructure. And so to be more precise, let's have a look on how this exactly works. It's just really to let you know how we are going to work back in the scenes. So one of the solutions of this type of solutions, a very popular one, is Docker, okay? And Docker provides the following architecture. It is a 3-level architecture where you have something that is called a Docker registry. A Docker registry is a service, okay, that contains what we call images. Images are self-contained virtualizations of something that we are going to use. For example, in our case, today we are going to use a Mongo server with some data that we have prepared for sharding and running in a Linux-like environment. And so you are not going to install neither Linux, neither Mongo, nothing. This package will contain everything, okay? And the description of all the tools that we are going to use is called an image, okay? And as you have seen in the previous hands-on, it is sometimes difficult to get together all these elements that we need. For example, for using Mongo, you have to, for example, to prepare your to have a shell, and some of you didn't have the shell, and so on. So to install things. Okay. So instead of this, we will have all the description of everything necessary that we are going to use, and this is called an image. And this is a kind of business thing in the computer science arena. You know, people and companies do their business building images. Okay, for example, for data science, we will, at the end of our intervention, we will have a vision of data science. So people use different tools, and they integrate this set of tools for others, and they propose images. So you can build your own image, but it is also possible to use images that are available on the net. And for example, Docker, what it proposes is something that is called Docker Hub, where people have have available different images. We are going to use one that has been already prepared in Docker Hub, okay? So once you have these templates of descriptions of these running environments, then when you start using it, what you're going to do is you are going to build what we call a container. This is a template, and this is a real instance with all the tools necessary that will be running, okay? And containers, which are little machines, if you want, are installed in a host. For example, the host can be your machine, or a cloud, or a cluster, or whatever, okay? And the host will have a Docker daemon that will control the different containers that we can have access to. It's like having access to different machines. So you have someone saying, now I want to access my iPad. Now I want to access my personal computer. Now I want to access the server at NCMAC, okay? And so you access these different containers, and this Docker daemon helps you to do that. And once you have the containers, it's like having little servers, then you can have what we call a Docker client that will retrieve these running things, or include other elements in the containers, and then you can manipulate containers. Here, what I'm saying when I say manipulate is you are manipulating running environments that you will use for developing something, okay? So this is a very crunchy description of a Docker architecture. Virtualization is a topic in distributed systems, but it's a way of letting you understand which are the elements that we are going to use in this hands-on. If you are really interested in this cool topic, I put the link to an initial tutorial on Docker, and you will see that possibilities are a lot. Now, how do we use this? Well, we can either, as we have been doing in the classic manner, use our machine and then install Docker and then retrieve the necessary images that we need, and then etc. as the classic solution. But what I wanted to show you is a way of externalizing everything, including the machine, so that the only thing that you need in order to do the hands-on is a browser and a connection. Not VPN, just an internet connection. Okay, so you just need a machine with your browser and your internet connection more or less stable, so that we can run the hands-on and externalize everything. How does it work? Well, part of the of this Docker community has created a kind of sandbox for people more or less like us. Sometimes you do not need really to install a cluster or to access a real cluster or to access a real cloud and configure an environment in order to test some things, okay? For example, we are going to run an experiment. We are going to get acquainted to different tools in order to shard our data. And we are not expected now to build a cluster and configure all of this in order just to have this little touch on these ideas. This happens a lot when you run data science exercises, particularly experiments. You just want to have a set of data, you want to explore them. Some algorithms are greedy, so you need more or less important computing resources, but you're just testing. So you need something easy to use that lets you run your tests, and eventually when you decide how things which are your requirements and what you really want to design, then you go to more stable environments and then you design a real solution. Okay, so Docker provides this kind of environment. It is a sandbox called Play with Docker. The initial intention is to let people start learning to use Docker, okay? In our case, it's just externalizing and having a sandbox in order to share data with Mongo. So this Play with Docker, in fact, is a kind of cloud that provides resources or servers. You can decide whether to use one server, or you can decide to use and configure a cluster of servers that will be running in the Docker Hub environment, which is you can consider that it is a kind of cloud. Okay, so you will tell it, I want to have a cluster of 5 machines with these characteristics, or I want to use a server of these characteristics, and then they provide you with the resource and you start using it at this distance. So this Docker playground allows different things. It allows to have Linux virtual machines. It also allows to run Docker containers, which is something that we're going to do because we're going to use a special tools, particularly Mongo, for the hands-on. And then you can create clusters, as I had previously said. And the only connection that you need is your browser on the site of Play with Docker. Okay. So in the case of the hands-on, it's a little more complex because we are going to, in fact, what we did is we prepared the image that, the image that we wanted to use in order to do the sharding hands-on. And this description of the image, we stored it on an environment very well known today, which is GitHub. GitHub lets you manage code, okay, versions of code with all the necessary libraries in order to build applications. So it's very, a very a popular environment for people that code and that want to share code with specific communities. So we use this in order to describe the infrastructure that we were going to use in this hands-on. And the Docker description contains the Mongo version that we need, the description, and the data that we need, okay? And what we're going to do is the following. We are first going to, so the central part of our execution environment will be play with Docker, where we will have an initial devoted server. This part is the one that you have done offline according to the instructions I sent 2 days ago. So you created an account on on Docker Hub, then you initialized play with Docker. In your browser, you created an instance of a server, okay? And today what we're going to do is, using this, we're going to retrieve from Docker Hub an image of what we specified in this GitHub, and we will install it on the server that we have created on Docker Play. And once we will have this, then we will start sharding, well, getting the data and sharding our data. Okay, so again, for those that arrived a little bit late, or for which I spoke a little bit fast, there are two objectives here. The first one is configuring a complete externalized environment in order to test sharding with Mongo, okay? So these are the two things that we are going to do. Again, there are some questions during the hands-on, but particularly the idea is that we together, so you together with me, follow all the steps of the hands-on so that I can show you and that we can discuss together how this infrastructure is working, how the sharding will be working, and what are the interesting aspects to see and connect them eventually to the theory part that has been proposed in the previous sessions, okay? So this is a general overview of the hands-on, and so let's go for it. I'm going to change to share my whole desktop. So I suppose that now you will have access to my whole desktop. You will tell me in a minute, do you see this PDF? Sorry. So please cry out if you don't see my PDF. So this is the one that I shared and sent to you, sorry, some days ago. Okay, so just to be sure that we are all on the same page, what you have to do is create an account on Docker Hub. Okay, if you didn't, please do now. Okay, it's just giving an email and a password, so it's nothing difficult. And then you go to play with Docker. Okay, so I will show you how does it look like. So, well, I started running in 1 hour ago, almost 2 hours ago. You must know that we are using a sandbox. So the servers have a short life. They give you 4 hours server in order to work with it, okay? At the end of the 4 hours, if we need to work further, we have to initiate a server again and do things again. So this is the not very nice part of it, but it is because we are just testing and using this sandbox to test something, not to build real applications. Okay, so the first thing to do, so I want feedback from you in order to be sure that the 30 people here, or almost the 30, because I think that Iragael and Christophe are also connected, but for the rest, so if you are a student, please tell me when you are in this situation. So when you go to play, so click on play to Docker. With Docker, you already have an account, so you will have the little fish on the browser. You click on start and you will land to a page that looks like this, okay? You add a new instance, and what you will create, you will end up with this, which is the same situation that I have here. Of course, you will have more time available to work, okay? So that's the first milestone to achieve for now. So don't hesitate either to tell me on Slack or in the chat or opening your mic when you are ready with this. Remember that the idea is that we work together. So synchronization is a very hard thing to do, but let's be crazy and try to synchronize all of us. I have so the chat will be, attention, the chat will be on my screen. So very good. Very cool. Okay, just to have a little explanation while you are confirming. So here you have the remaining time that you have for your server running. You have the ID of the server. You have an IP, so it is possible, in fact, to connect from an application to the server. Okay. You have the characteristics of the resources and the amount of things that the amount of resources that you're using. Then you can you also have the SSH IP address, and then you have this sandbox. This is your shell. But instead of having your shell on your machine, now you have a shell on the browser, and this is the one that we are going to use in the hands-on. I'm going to put an address, if I get to see my other diaporama. I'm going to close this. Yes, I'm going to copy this address, and I want you to go to this address. So I think that everyone, sorry, Lulico, I just sent the address only to you. I'm going to put it here for everyone, sorry. So if you, excellent. If you, so let's go. I think that nobody has problems, so let's go to the next step. We are going to now to have a look at what we have in this GitHub space, okay? So in order to access to this GitHub, please click on the link. You are going to land to something like this. So I'm going to put these screens, these pop-ups here. And what you have, well, of course, you can have an account and then manage your code if you are you like coding and you want to manage your code there. So you can have an account. And when you, in fact, GitHub, where you create projects on GitHub, and each project, in fact, will be code and description of the code, and you have these markdown descriptions that essentially explain what is your project, what you are programming, what is the type of code you are sharing, whether there are releases, whether there are versions, whether you need packages, which is the type of languages that are associated to this code. So all the necessary metadata that describe your code. And then you can either download the code or connect remotely to GitHub in order to receive the different updates that people are producing related to this code. Okay, but we are going to use it in a very, very simple manner. What we have done is that we have prepared this famous image that we are going to use in the hands-on. It contains data. We are going to use a data set that describes cities in the USA. It has nothing to do with elections these days, but it only contains information about different cities around the US with information, general information about these cities. And then what you have is this Docker compose .yml, which is the description of all the things that the image must contain. Okay, I'm not going to go too much into these technical details. Normally, this is prepared by the person that designs the execution infrastructure. Okay. And in here, this markdown, we used it also to describe the hands-on. It's not intended really to be used exactly for this, but we used this to also to describe what we're going to do during this session. So if you go down, you scroll your screen, we have requirements. So we are using option number 1, which is we're going to use play with Docker, okay? You could use it locally, but we are not going to do this in this hands-on. Now, once we have this, we need, as I showed in my slides, we need to do this procedure, which is, as I said, we are using an image, public image that is proposed by Docker Hub, and we are going through the description, the YML description that is stored in GitHub. We are going to get this and install it here. I have a nice animation, you know, it's like this that we're going to do to prepare, so to configure the server that we now have available, okay? So in order to do this, it's really copy paste that we're going to do, okay? So first of all, what we're going to do is we are going to get particularly these YMLs, which are the description of the images we are going to use. We are going to clone them on the server that Play with Docker has created for us, okay? So you can copy this line. So it says GitHub, so this is Git, clone, so have a copy contained in this address. Okay, that's the interpretation of the command. Okay, so we go back to our browser, we go to our server, and I'm going to copy. Okay, so remember that the dollar icon is called prompt. Okay, so the prompt, to the right of the prompt, I copy my instruction, and then it says, okay, I'm cloning what is contained in this address in DX lab sharding, which is here, and etc. So it's remote, and now what we have is the description of the image we are going to use in the server. So second milestone, cloning the image on the server. So again, please let me know if you're ready. Cool. Excellent. I think that most of us are ready. Do not hesitate to take the mic if something weird happens. Very nice. Okay, so the second thing we're going to do, so okay, we have the description, this image template, and now we are going, this template is contained in this folder. So in fact, what we did is we got this organization. So I have one folder and then one folder and a set of files. So this is what I retrieved to the server. So I'm going to go to this IMG, okay, folder. Oh no, to the DX lab sharding. So to the folder that contains everything I retrieved from GitHub. So remember, those that are not very acquainted with Unix, when you do CD, you are accessing a folder in the space that you are, and then you give the name. Okay. So again, we copy, and now I am in the folder DXLab. And once I am in the folder, in this folder, you have particularly, as I explained previously, this Docker compose.yml description. This is the thing that says, please, Docker, build a running environment that contains everything that I am listing here, okay? I'm being a little bit schematic, but it's what it says, okay? So it's just a kind of script, okay, that says all this. And and it's going to compose the running environment, okay? So we are going to do this on the server. So Docker compose and then pull, get this from there. And it's like sending missiles because it starts pulling, and but well, it's doing all this, okay? And if you have a little look at what it's doing, I don't know why I have an error. I am coming back for this. Ah, yes, I don't have space left. This shouldn't be happening to you. Why do I have an error? Because I'm online, and of course, online, there are things that always happen. Okay. Just tell me if you could. I'm going to create myself another instance, but just tell me if you could do the compose without errors, please.
Yes, for me it worked well.
It worked, yeah. It's a problem that I have, certainly, because I've been playing with it previously to the hands-on, so I am certainly doing something wrong. But
for me, there is an error message.
Like the one I have? You see this kind of, do you have the same kind of error that I have? Well, or a similar one. I think that, yeah, it continues. I'm going to create a new instance, okay? But
Yes, the exact
the same error, okay. I'm going to create
one.
an instance, and I will tell you in a while. So those that work, we can continue, and then I will stop a little moment to fix my error and your error, and then synchronize with you. So are we, I don't know who you are we, okay, so Sofian,
yes, same kind of error.
Sofian, me, and I don't know your name, it's, we are the three that have the error. That's right. We're the unlucky.
The error as well. Yeah.
Okay, so just give me a second so that I can figure out what happened. Lulico too. So I'm going to give instructions for those that do not have the error, and I'm going back to those that have the error, including me, okay? So for those for which the pool, the compose worked, you can try. In fact, what happened is that you got your everything you need from the GitHub, and in order to be sure that this is true, you can put the instruction Docker images, and there you will see that your image has been created. And if you see it, then you rock. Okay, so you are ready to start now playing with the other part of the hands-on, which is preparing a cluster for sharding data on Mongo. Okay, so I'm going to do a little pause here. I'm going to go back to those, including me, that have the error, and then we synchronize with you. Okay, so I'm going just to turn off my camera a little moment so that I can concentrate and see what's going on, and then I come back to the scene. I'm going to do that. But I'm going to do now, which is the cheesy part. So we're going to configure a cluster with one router, with one, in fact, the official name is query router because it routes queries, okay? So we are going to have one query router, one config server, and 3 shards, okay? This is going to be our cluster. Okay, so how do we do this? This has already been defined by me and my colleagues for you, okay? So this is contained already in the Docker. So we are going to do the following. We are going to, for the time being, what we have done is we just have everything necessary in the server we have available, but now we have to execute the environment. So we are going to say Docker compose up in order to start containers, so that they can start running and we can use them. And what are we going to start? In fact, we are going to start running a Mongo so that we can start configuring our cluster. So I'm going to go back to my server. So if you have a look, we are having a config server, the shards I described, and the entry point in Mongo, it's called CLI, okay, and a query router, okay. So these are all the elements that we are going to use. Remember that we are hiding this complexity for the sake of pedagogy, okay? Of course, if you could do this by hand, but we don't think that this is very important for you to really do. Instead, understanding how to design a cluster, this is what it's, from our point of view, interesting in the case of this lecture. So again, let me know when you have your 3 shards, config server, and query router, and CLI. So remember that, in fact, I'm going to use this figure. What we have is, we are here, very happy to be using this tool. We will have access to CLI, which is the one that is here. You see, CLI. Then we will have a query router. In the case of our configuration, it is called query router.docker. We have a config server that contains the metadata about the collections. And then we have 3 Mongo servers, which are name, shard, and number.docker, okay? So these are empty. These are just 3 Mongo servers, a process which is called config server, a process which is called router, and a process which is called CLI, okay? Nothing inside, just the cluster. Configuration. Now we are going to run all this, and particularly we're going to start running the CLI. Not running, entering the CLI. Now we have a different prompt. It says that it's root 3 ñ, which is the prompt of the CLI process. So we are now here. We are connected here. This alarm is just telling me that it is 11. Okay. So the objective, before we decide whether we stop or whether we really continue without a break, because you have been working for a while without breaks, but let's say that we divide the collection and then we decide, okay? So now we are, as I said, we are here. We are connected to CLI. Now we are going to ask to connect, so to this connection, to connect to the router. Note that now we are saying that we are going to connect to Mongo and to a query router. Okay. So remember that now we are on the CLI and we are asking it to host a query router. Okay. So what we have said in this instruction is, please CLI consider query router.docker. Let's connect to it. Remember that we are just configuring the cluster. Eh? Now that we have the router, we are going to connect the shards to the router. Okay, it's like shaking hands and doing presentations. You create your CLI, then you present your router to it. So please shake hands. Okay, now you get to know each other. Now you are going to introduce the different shards to the query router so that they can establish communication among it, well, between each other. So the router and each of the shards.
Excuse me, I have a question.
Yes.
I tried to connect to the router using this command, but it's written connection failed.
Did you execute the previous one? Did you execute this one, the CLI?
Yes,
No,
I have a root.
Okay.
And
And
it's written a failed temporary failure in name resolution. Error couldn't initialize connection to host query
there's a
router.
problem in the. Are you sure that you didn't copy a kind of letter that you really did copy paste with the correct name?
Well, yeah.
So give
I
me
can
just
show.
a second, and then you share your screen with me, and we see. Okay. Okay. If you want to parallelize, you can put a copy of your screen on Slack, and I can see meanwhile.
Okay, I think it works.
Okay. So yeah. Excellent. Remember, that's a general announcement. If you feel that you are having problems, but that at the same time speaking, do not hesitate to put your questions either on the chat, but I think that in the chat you cannot share images or things like that. So go to the Slack. I'm monitoring the Slack, so I will react as soon as I can. Okay, so now, as I said, we're going to shake hands. Yeah.
Madame, can I speak to you in French, please?
Yes, go ahead. I'll do my best.
Or I can
Yeah,
go on
go
in English.
ahead, go ahead.
I'm sorry, but I'm going to return to the interlab folder at the beginning because I'm trying to code the beginning since more than 10 minutes.
Yeah.
And I can't access to CD, DXLab, etc. It doesn't
but
work
we're
for me
not there.
at all.
At all. No, we are
Sorry?
just before. We are before
At the beginning?
inserting and querying data. So if you give me some
Yes.
seconds, then we can reach you. Okay. We are just
Didn't understand
three
because of
instructions.
my connection.
3 instructions from you. No, 2 instructions. So we're coming. Now we are going to change database and to add clusters, to add our shards, to declare our shards to the cluster, okay? So we are going to be administrators. And then we are going to create in this administration space our shards. So use admin. This one you know already because you did a similar manipulation on the previous hands-on. So note that now I am in MongoS. So I'm in the query router. So now I'm in the database admin, and in the database admin, I will add my shard. I'm adding the first shard. So my shard has been added and successfully. What I'm doing is the following. I am connecting, I am in the administration, the database of query router, and I am declaring these shards on it. Okay, that's what I'm doing. And every time I do things on the cluster, since now I have a piece of cluster, you see, I have my CLI, I have my router, and I have one shard. So I can ask about the status. So if I ask about the status of my, of my cluster, well, it says that it's a document, you see, it's just a description. I have, it says the version, it says that it's compatible with a previous version, number 5. It gives me the ID of my cluster. It says that it has only one shard. The shard is, logic name is shard1, and the real name is shard1.docker, and the ID of the host. It has a load balancer. It says that it is enabled, but it's not currently running. It says that for the time being, there haven't been errors. And that there hadn't been migrations. In fact, what happens is that the cluster, the system, once you have a cluster, it starts balancing the weight of the shards, of the data that are contained in the different shards. So sometimes it automatically migrates data from one shard to another. And so here it says that for the time being, there haven't been any migrations. And it says that for the time being, the database that we have is the primary one, okay? And like this, normally while our cluster is running, this part will change because the cluster will be alive and things will have been going on. So you will have, if you execute at different moments this status, then you will have different information. Now, we are going to disconnect from the router, okay? So now we are connected to the router. We are going to stop being connected to the router because we are going to start preparing. Now that we have the router, we are going to start the cluster, the piece of cluster. We're going to start distributing our data within it, okay? So with Control-C, you stop your MongoS, which is the router, I remind you. So you see, well, bye, from the router, and now I am back to root, to my previous status. So one of the questions was what important information you can see in SH status. I have explained what is important is that if at some point you come back to the hands-on, this is some information that you have to keep in mind to be able to interpret the kind of information that you have about the status of your cluster. So we are doing homework together. So I think that we are reaching the part where your classmate had a question, if I understood well. So now what we are going to do is the following. We are going to import to the query router to a database called My Database, the collection cities, which is contained in the file cities.txt. Okay, this is what says this piece of instruction. Remember that you have to disconnect from the query router first. You know that you are disconnected from the query router because you see this prompt. So the name of your server. Okay, so when you see this prompt, then you put this command. So what does it say? It says that it's connected to the query router. Okay, being disconnected from the query router doesn't mean that the query router is not still running. The query router is running. The only thing is that we have disconnected from it. And we connected to it in a different manner. So through this instruction, okay? So here we are saying that we want to do this piece of instructions on top of the query router. So what we did is, as I said, we connected to the query router, which is this instruction, and then we imported in the database, my database, this collection. Okay, so we imported almost 30K documents, no? So now we are very happy because we have imported our data on the query router. So we are going to connect again to the query router in order to have a look to the database we have created, okay? And this is something that you master now because you have been doing hands-on number 1. So we connect again to the query router. Remember that you know that you are connected because you have the prompt Mongo S. Remember always that Mongo S is the prompt of the query router, the blue one. And this, you know, we are going to ask it to list the set of databases that it contains. A query router, a Mongo query router is a kind of Mongo, the one that you have been using, okay? It's just that it has a little bit of more power. So you have admin, which is empty. You have config with this number of gigabytes, and the biggest one is my database, my DB, because it is there where we store the cities data collection. And this again, you know perfectly. We are going to go to the database MyDB. We are there. We're going to ask it to tell us the list of collections that it contains. Again, this one you know also. So note that we have cities, and today you have been playing with indexes. So you have system.indexes. I suppose that for the time, I think, I don't know, Christoph can help us with this. It creates initially one, no? Index. And then here you perfectly know what we're doing. I don't know if you, we're going to do in 2 steps. We are going to, that you know, we are going to observe the content of cities. So we have this mess, and with my, if you say fine, but put it pretty, it organizes it like this, okay? This is because we are working on this shell screen, and that, as you know, it's a little bit of burden to see the results, but then it formats more or less the results so that we can explore them a little bit. And we can, for example, but this is something that you have been playing with, we can instead ask it how many documents do you have? And we have the corresponding, you see, it's the same size that the one that reported our first instruction when we executed it. I just somewhere here, sorry. At some point I explained this, but now so many. And here, well, this was part of the hands-on. The idea was, this hands-on was created supposing that people were not really acquainted on the documents, on the way documents are managed in MongoDB. Okay, so this is the reason of this question, but now this question doesn't have any sense to in this hands-on, at least for you, because you have extensively work with Mongo. So, so let me see, what time is it? Okay. So just to sum up what we have been doing until now, we did a technical part, which was designing a first cluster with a shard, with a query router, with a config server, and with an entry point called CLI, okay? We also created a data collection in a database, my database, at the level of the router, okay? For the time being, nothing is contained in the shards. Now, once we have this initial data collection, the first question that we have to ask is, which is the best strategy to adopt in order to fragment it? Well, this is a complex decision to make. In fact, if we were doing it professionally, what we would have to do is go and see the distribution of the attributes of the values of the attributes of our documents, okay? To decide about 3 types of, and also one is the content of the data collection, and another thing is the type of queries that we would like to answer to, okay? So these 2 elements would guide the sharding strategy, the best sharding strategy that we would adopt for the city's data collection. Okay. Mongo proposes 3 types of strategies. It proposes a strategy based on intervals. When you have to decide a strategy, you have to decide with respect to which attribute of the document you are going to fragment your data. Okay? It is more or less the same, even if, I mean, mathematically it is not the same. It is more or less, you remember that when Christophe explained us the fragmentation, particularly the vertical one, you reasoned with respect to the key of the relation, because in relational databases, the key is the major attribute with respect to which we are going to reason about. Yet here in a document-based data model, there is no longer any key. So the difficulty of choosing which is the attribute or the set of attributes with respect to which we are going to fragment the data collection depends on the distribution of the values of the attributes, okay? If I have attributes for which it is natural to reason on intervals, for example, if I have an attribute age, normally I could reason, for example, about an age from 0 to 15, then 15 to 20, and so on and so forth, okay? And if I have a normal distribution on the ages, this can be a very interesting way of fragmenting my collection, okay? And then I could combine attributes, things like that. But you know, that's the kind of reasoning that we would have to do in order to determine whether the strategy interval-based fragmentation it would be well adapted for our collection. The second strategy proposed by Mongo is hash-based. When we have very non-homogeneous distributions of the attributes, considering intervals will lead us to very small fragments from a given interval and very huge ones for other shards, okay? For example, if I have a data collection where I have people aged, a lot of people aged from 20 to 45, and very few people aged under 20, I will end up, if I have two shards, I will end up with a very small data collection of those people under 20 and a huge thing of people from 20 to 45. And again, in the first theory lesson, we learned that the idea of fragmenting is also to have an homogeneous size of the fragments, so that in fact we do not very often go, and we know that we query a lot, for example, 20 to 40. I will not go very often to 20 to 40 and almost never to the server that contains people under 20, for example, because that creates performance issues. Okay. So if this is not the case, it is possible to reason on hash functions. So a hash function, what will let you do is have an homogeneous representation or model of the different distributions. So you will have buckets more or less of the same type with respect to a hash function. I will not lecture on hash functions. Sorry, tell me. I have a question.
I would please, I'm sorry, I'm in the class.
Can you repeat? I didn't hear well. Was on my cloud.
Okay, okay, thank you. All right.
Sorry, is it with us or without us? I'm going to open there and close his mic. Ibra, you have your mic open, and I think that you are not talking to us.
My session expired. I don't know why. So
your session is over because you started playing before the lecture with the server.
Yeah, but I had enough time. I still had I started my session around just few minutes before the class, but
Yeah, that was the same problem that I had. And what I had to do is restart my session and create a new server.
okay.
So you have to do that.
I'm just following now. So
Good.
after the class, I
Yeah, no problem.
just
I will
go
not
back and then.
control completely. I mean, just be sure that you follow and that you eventually do it on your own. And again, if you need something, you can Slack me. And by the way, I am going to control Slack because, you know, I have many Slacks, so maybe it's not here, but I want to make sure that it doesn't, it's not a question here, but somewhere else. I do have a question here. You don't have a problem, Huda. This is the prompt of your root. We have Huda who is having a look to this state of the, I'm sorry, you are here. You see, you are like this. The root at and the number says that you are connected to the server, but that's not a problem. It's just the prompt.
Yeah, but I can't continue to write the others command.
You cannot copy paste? You can, no?
I don't think so.
Are you trying to type near the prompt? Just try to copy this Mongo import instruction.
Okay.
And if you can't, please send again a copy of your screen on Slack and I can go back to it, okay?
Okay, thank you.
Cool. Okay, so that was the hash, and then later on we will see that we can explicitly say from which to which value. It's a kind of interval-based solution, but it is only associated to an application requirement or context requirement, not a content-based strategy, okay? For the time being, we are going to see how does it work with range-based partitioning and with hash-based partitioning. And at the very end, I don't know if in this session or in the next session, we will have a look to the last strategy. So let's start partitioning with range-based partitioning. I remind you that we are at the blue level, so we are here. And the data collection, complete data collection, is sitting here in the router, okay? And now we are going to tell the router to shard this data collection with a range-based strategy. So we are going to say, create a data collection, well, the data collection cities, be aware that we are in the router, and that I can, oh yes. So we have created this data collection. This you know how to do because you have been doing this in the first hands-on. Now we say, just to make sure that it is there, we say show data collections, and it is already sitting here. So note that we have the cities, which is the initial one, and now we are creating an additional one called cities one, okay? So what we are doing is we are creating a container that will host a piece of the initial cities data collection, okay? And the way we are going to choose the documents that will go to cities one is according to an interval, okay? So it's more or less the same as the operations you did in hands-on number 1, where you copied the database in order to manipulate it, in order to update it. Here we are creating cities 1, and we are going, well, sorry, and we are going to associate a piece of it in the cities data collection. I'm going to ask you to give me a minute, because otherwise.
The microphone is off.
Yeah, so
Sorry. So we are going to create, to say that we are going to enable the sharding of my database, which is the one that we created before. Wow. And now we are going to shard the collection on my data that will be contained in my database cities 1. So let's have a try. So we enabled sharding of my database, and now we are going to shard cities here. And what do? Well, we have a look on the status to see how did it change. So let's have a look to this. Sorry, I'm going to put you here. So again, this is the same information that we had. What is interesting is to see this part. So we are saying, it says that in the database admin, it is partitioned, it's not partitioned, and it is the primary version, okay? So this is the initial one, okay? So now it says, which corresponds to the previous instruction, that the database, my database, has been partitioned. It is the primary shard, the primary fragment, and it is called shard 1. And then it also says that it's using a minimum key and a maximum key for the time being. It has just created the interval. It hasn't determined the limits of the interval. It just says that we are going to use an interval strategy. So I'm just going to come here, and I will come back to those that might have technical problems, okay? So now what I have is a container, but I need to fill in the container. So here I'm going to fill the container with a piece of my data collection. Here it is. And it will get a little bit of time, because what it's doing is kind of the same procedure that you did by copying the database, the initial database to another database, but the only difference is here is that it's copying a piece of it, considering an interval, and to something that is declared as shard, okay? When you have something declared as shard, then the system, Mongo, will take control on it and will monitor its size, how it is divided. We will see in some minutes that the shard is in fact composed of several chunks, several pieces, and whether the chunks can go from one server to another, okay? So it's just that Mongo treats this new collection as a special one that has been sharded, which means that it belongs to something global, and that it will be treated as a piece of this across the cluster, okay? So while I go back to those that are having little problems, I will let you have a look at status to see how it changed now that we have inserted documents into our first shard called cities1. So I'm going to run it, and then I will go back to the other problems. So just let me have a look at Slack. So so first is first. Huda, could you do a copy paste and continue working on the server?
Yes.
Okay. So, okay, now, Sofian, let me see your error. Okay, that's the first one. I'm trying to figure out your error, Sofian. I'm going to test it separately and come back to you, Sofian, in a second, okay?
Okay.
So meanwhile, what do we see in the status? Well, we see interesting things. We see that, in fact, it has started creating pieces of our shards. Note that what we did is we used the attribute state of all the documents as shard key. So I've been going a little bit fast on the explanations. If you go back and have a look in detail about the structure of your documents, you will see that one attribute of the documents describing our cities is state. And in this first try to shard the collection with respect to an attribute, we chose state with the idea that we are going to organize all the cities belonging to each state together, okay? And so we are going, in fact, to groups of states in each of the shards that we are going to create, okay? And the interval is a lexicographic interval, okay? So we have the minimum key, so the first part of the interval of the lexicographic, the alphabetical order, okay? Until MA is contained in the first shard. Then from MA to states starting with RI is the second interval, and we have a third interval from RI to the maximum key, so those that would start with Z or with T or with S, no? Depending on the type of names that we have, okay? So we end up with 3 shards contained in the first server called shard 1, okay? So we have, just let me come back to my, I'm going to have a look at the Slack in a minute, okay? I know that there is a question. So for the time being, we have created this, okay? We have a first, and now the data collection which was sitting here has been divided here into 3 pieces. One from, with respect to the attribute state, one from A to MA, the beginning of the word MA, then MA to RI, and then RI to states name starting with S, for example. Okay, and the 3 pieces are sitting in this server. Okay. This is what this status is now saying. Now, there is other interesting thing is that every fragmentation operation is timestamped, okay? This timestamp will help for consolidating copies, for example, for dealing with copies consolidation. Christoph has explained much more better than myself, okay? But this is useful for the system for this kind of operations. What time is it? Okay. We're going to stop here. So what we have done until now is a lot. Okay, we have learned again how to configure a cluster containing 1 query router, 1 config server, and for the time being, we only have 1 shard server. Okay, we have learned how to fragment a data collection into shards using an interval-based strategy given a shard key, okay? The shard key, remember, is an attribute we choose to serve as reference in order to create our fragments. And all these little fragments are sitting now in our server that belongs to the rest of the cluster called shard 1, okay, the green one. So the question here, now, these little pieces of, I'm going to go here, these little pieces of data collections in the MongoDB jargon are called chunks, okay? So in a shard, we can have several chunks. In our case, we have 3 with the interval-based strategy. And as I said before, explicitly or implicitly, the system can decide whether or not to migrate chunks across the different shards. When does it decide to do this? For example, if it's running out of space. So it can decide to migrate one to a shard that would have still available space. That's an example of migration. This can be delegated to Mongo, or you as a database manager can decide whether to migrate chunks or not. So in order that I can help some people with technical problems that they're having, I let you in the last 15 minutes, I let you have a look at the hash-based partitioning, okay? It's more or less the same set of instructions, but here the only difference note here is that instead of interval, you are choosing the hashed option. So you are asking it to consider this, and then you can have a look at how does it look like, particularly in status. How many, for example, the question is, how many shards do you get when you use this hash-based strategy, okay? So I let you do this in the last minutes that, that we have. And meanwhile, I'm going to go back to those that have technical issues. I'm going to stop my camera for a moment. And so I'm coming back. I'm here on the mic, okay? Sophia, and I'm trying to have a look at your problem, and I don't understand why you do that. Have you tried to uh, again with the instruction? It's a kind of weird thing. I'm just trying to reproduce the error, and it's not. I don't get.
Yes, I tried 2 times and I got the same error. I think I'll try again and see if
Yeah. Otherwise,
I don't know.
we can interact I mean, point to point by sharing your screen, etc. To see, you know. But by the end of the session, if you have 5 minutes, we can do this.
Okay, yes,
Okay.
yes, I would appreciate that. Thank you.
Okay. So what I propose is that we do together this last hash-based strategy, so that I can comment on the status, and we can close today's session. And what will happen is that next week, I don't know if Irakael, are you still here? Well, what will happen is that we will start at 8. The session will be starting at 8 next week, so that we can finish this hands-on together. It's a very short part that we still have to address, and then we go to little bit different things, which is we're going to start with data science experiments and with data analytics aspects, which would be the last part of the big data part, okay, of the lecture. So let me share my screen again so that we can have a look on this. Okay. So now you should be having a look at my browser. So again, what we are doing here is we are creating another container called cities2, and we want to see it, whether it creates it on the router. Okay, so I don't know what I did. What did I do? Okay, so I'm going to copy again. Okay. So I create my cities2, which again is a container, and then I have the original one cities, the one that we hashed under an interval interval strategy, and then the one that we are sharding with respect to a hash-based strategy. So here we are asking to use cities2 to create fragments under the hashed strategy. So now we have this new cities2 in my database that contains the fragments, the chunks, to use the jargon of Mongo. And then let's have a look at the first status. We have this. And for the time being, look that we have my cities2 residing in our database, my database. And this shard is, these new shards are contained in the, remember that the green one, the server, is called shard1. And in this time, we have only two shards, two pieces, two chunks, sorry. One that goes from a minimum value to a value. Note that here it refers to the value created by the hash function. Okay, the hash function, what it creates is a function that will create keys that will serve as reference to identify a set of items. Okay. There are many different hash functions. Mongo has a predefined one that we give as entry, again, the attribute state, a string, in fact, we give as entry a string. It creates a value, and this value serves as reference in order to group the data into what we call buckets, okay? So in this time, we have only two buckets. One that goes from a minimum key to a value of the hash function represented by this reference, and from this reference to a maximum value, okay? And now let's fill in both chunks. Yeah. So we are going to fill our chunks, documents. So note that the documents will be all documents from A to a given value represented by the hash, and from that value of the hash to the value corresponding to the documents where state is the maximum value. So states starting with S or with Z, if there are. So we wait a little so that I can create the chunks and fill them in. And okay. And let's have a look at the status. Well, now, no, the following. So we have the first ones that we created with the first three chunks that we created with the interval-based strategy. And we have now 4 chunks created out of the initial cities, but with the hash function. So first of all, here, what it created is 2, in the previous status, we had only 2 with only the maximum and the minimum and the maximum value of the hash function. Okay, so initially it only creates 2 with the maximum and the minimum. And then when we really give values for every document, it creates a value, and then it can further define more pieces, okay? So in this case, we have 4 pieces from minimum to a number, from that number to this number, which corresponds to the hash function value, from this to another, from this to the maximum. Again, the advantage of this is that normally hash functions are normalized, okay? The distribution of the values are normal. And this means that your chunks will have more or less the same number of documents, okay? Which is very interesting, again, given the fact that we are always more or less looking to have a smooth distribution of the size of the pieces of the collections, okay, across the elements of the cluster. So with this, we are going to finish this session. So as I said, what we will have a look in at 8 next week will be how these chunks are organized across a cluster, which is an interesting thing to do. Particularly, again, remember that the idea is to show you in practice something that we have addressed in the theory part of the lecture, okay? So that you can have a look on how mechanically this works. And again, what happens when we go from home playing with the data to context where we really need more resources to be much more flexible with respect to technical issues and play anyway with important volumes of data. So we will do this, and then we will have a look at the third strategy, that is a semantic-based strategy, which is also interesting, and we will discuss particularly what it is important is to discuss with respect to queries, which would be the advantages of the different techniques regarding the performance, potential performance of query management of these settings, okay? So again, if you have questions, there is always Slack. I'm completely connected to Slack, so I can really answer very, very quickly to eventual questions that you have. Remember that you don't have to send any results to this, because we are doing this together. So once we will get into data science experiments, then you will have to upload things. But for the time being, is really understanding how it works and identifying the different strategies, and that's all. Okay, so I'm going to stop registering.